Good afternoon, everybody. Welcome to this webinar entitled Introduction to the Nuts and Bolts of Quantitative Evaluation. We're very fortunate today to have Dr. Nadine Persaud with us to deliver the presentation. She's a lecturer at the University of the West Indies in Cave Hill, Barbados, and was the program coordinator from the Masters of Science Project Management and Evaluation degree during the period 2009 to 2016. Nadine is a very busy lady. She serves on a number of international organizations, including as the chair of the Finance Advisory Board of the American Evaluation Association, director of the Chartered Professional Accountants in Canada and the Barbados chapter, and advisory board member of the Faster Forward Fund in the US, which was established by founding evaluation pioneer, Professor Michael Scriven. Many of you will know his name. The fund is to accelerate the theory, practice, and profession of evaluation. Nadine has a number of publications, including papers and articles on evaluation, accounting, and research methods. And she has co-authored a book entitled Research Methodology Basics, from Conceptualization to Write-Up. Her book, Strengthening Evaluation Culture in the English-Speaking Commonwealth Caribbean, a guide for evaluation practitioners and decision makers in the public, private, and NGO sectors, is currently in press and will be released in 2020. As I said, we're fortunate to have Nadine. She's very busy and has a lecture coming right after this, so we will get right into the presentation. Over to you, Nadine.
Thank you, Valerie, and good evening again to everyone. It is a real pleasure to be able to present to you this evening on the introduction to nuts and bolts of quantitative evaluation. I'm assuming that most of you are new to this, and that if you are, it may be a little bit overwhelming. If you're already familiar with it, you may still pick up one or two things, but you should be familiar with most of the issues that will be discussed. But because of the title, we're assuming that people don't really have a lot of skills in quantitative methods as yet. And so I'm going to be pitching it to alert you to all of the issues that you need to be concerned with when you're doing quantitative evaluation, which, as I said, may be a little bit overwhelming. Paulette has already indicated that she's terrified of quantitative methods, but I indicated to her that if she's good at qualitative, that's much more difficult. So no need to be terrified about the quantitative methods. So the good news is that I'll try to pitch it so that you can try to gain some insight into all of the issues that we need to be aware of. But bear in mind that each of these issues could really take up an entire webinar on its own, because the issues can be quite complicated when you get into them to really understand them properly. The presentation will be made available to you after the webinar, so you will have all of the information that we're going to discuss this evening. Are you able to see the PowerPoint on the screen now, Valerie? Hello?
Yes, ma'am. Yes, it's there.
Okay.
Excellent.
So let's get started. So evaluators can design their evaluation using basically three designs: quantitative, qualitative, or mixed methods. Quantitative methods produce factual, reliable outcome data that are usually generalizable to some larger population. In contrast, qualitative methods generate rich, detailed, valid process data that usually leave the participants' perspectives intact. Those subscribing to the quantitative paradigm see the world as a set of objective phenomena that can be observed, measured, and analyzed in a highly systematic and structured manner. In contrast, those subscribing to the qualitative paradigm believe that different individuals and groups can provide quite different interpretations of the same phenomenon. For decades, there have been some heated debates about which approach is best. Today, many evaluators use a mixed methods design which combines both approaches. When the design is well designed and implemented, The evaluation benefits tremendously from the strengths of both traditions. Quantitative approaches provide the big picture, while qualitative approaches provide the detail necessary to understand the big picture. Today's webinar will focus on the quantitative paradigm, which is the most widely used approach in evaluation. Note, however, that whenever you are designing an evaluation, that you should use the methodology that would provide the most useful information about the program being evaluated, and not necessarily the methodology that you're comfortable with. As an evaluator, we need to have a good understanding of both quantitative and qualitative, as well as the strengths of a mixed method approach. So continuing with our definition of quantitative research, this methodology emphasizes the objective and quantifiable measurements of data. Specifically, it refers to observations that can be quantified into numerical form. For example, test scores, income, number of hours of service received, etc. This contrasts with qualitative data, which are generally reported in narrative rather than numbers. Note that I use the word generally since it is possible for qualitative data to sometimes be converted into numbers. For example, when frequency counts are used for various teams. There are a few things that you need to note about quantitative research. It is the most popular methodology utilized by evaluators. It expresses information in numerical form. It can test hypotheses or determine statistical significance between observation at 2 time periods or between groups. It uses basic descriptive statistics and inferential statistical analyses to analyze and report data. And data is frequently collected using surveys. So I think a webinar on surveys will be coming up in December, so you should mark your calendar for that if you would like to learn more about survey design. Once the evaluation objectives and questions are clear, the evaluator needs to consider a number of design issues. So using a quantitative approach really requires that you think about all of these issues that are going to be appearing on slides 4 and 5, which we're going to discuss in more detail as we move on throughout the presentation. So these considerations would include those pertaining to whether an experimental or a quasi-experimental design will be used, the sampling procedures and issues, data sources, reliability and validity, issues pertaining to the administration of the instrument, the levels of measurement that are appropriate for your data collection, and the types of data analysis, among others. Many of these decisions are influenced by cost considerations and the time frame for the evaluation. These decisions are also influenced by the evaluator's orientation and knowledge of various methodologies, and also sometimes client requests. So we are now going to go through each of these issues in some greater detail. According to Bramberg and colleagues, most quantitative program evaluation is based on one of 2 types of experiments to estimate the effects of treatments and interventions. We have randomized experiments and quasi-experiments. Both designs collect data that can be represented in numerical form, can be analyzed with descriptive and inferential statistics, and can test hypotheses or determine statistical significance between 2 time periods or between groups. With respect to experimental designs, these are commonly used in medical research, animal behavior and psychology investigation, but they're quite often used in many different types of research and evaluation endeavors, apart from these that are mentioned. The methodology includes random assignment of subjects to 2 groups. The first group is referred to as an experimental group and receives the treatment or program. The second group is referred to as a control group and may receive no treatment or program or a placebo. Although an experimental design is the most rigorous type of research design that can be utilized, there are a number of concerns with such designs. For example, there are often practical concerns about cost and logistical difficulties with administering a random allocation, including problems related to how participants are actually recruited. A major ethical concern pertains to withholding treatment to persons in the control group who may be in dire need of the treatment. Finally, Political concerns may include pressure from local politicians to include the entire population. This slide shows a number of different design configurations that can be used. There are literally dozens of design configurations depending on the type of study that you would actually be doing. And you can find those design options in many social science research textbooks. And the founding father of these designs are really Stanley and Campbell and Stanley, sorry. And you would find all of the designs actually listed in their original works. So if we look at these three design options that are on the screen at the moment, we can see we have some notation there, and the notation basically indicates that it is an experimental design by the indication of the letter R, which means random assignment. You will notice that the classical experimental design has two groups, as do the two group post-test only design. But in the classical experimental design, we're actually performing an observation before we actually administer the program or treatment, and then we conduct an observation after with both groups. This is actually a better type of design if we can do an observation beforehand, because we would actually have some credible baseline data against which we're then making a comparison. But sometimes it is not cost feasible, and so we just go directly to implementing the program or intervention and then observing after. But that's more difficult to actually observe the effects as in the first design. In the latter design, in the last design, sorry, we are actually using 4 groups, 2 of whom have obtained observation beforehand, and everyone get an observation after. So remember, the letters R mean random assignment, signifying that it is an experimental design, and therefore the results are generalizable to the entire population. The O refers to an observation, and the X shows an intervention or treatment. So similar to experimental designs, quasi-experimental designs also have 2 groups. The major distinction is that the participants are not randomly assigned in this methodology. Note also that the first group is referred to as a project group rather than an experimental group, while the second group is referred to as a comparison group rather than a control group. So basically, the fundamental difference between the experimental and quasi-experimental designs pertain to the random assignment of subjects, because in the first one, we can generalize, but whereas in a quasi-experimental design, because of the non-random assignment, we cannot make any generalizations. Often, the evaluator will have no control over the individuals or groups who participate in the program or receive the treatment or service, because the participants may be selected on the basis of administrative or political criteria, or the participants may self-select themselves. As a result, the comparison group will often differ from the program group in important ways that can significantly affect the interpretation of the evaluation findings. Therefore, if we are using this type of design, it would be advantageous if we could match our participants between the project and comparison group as closely as possible on demographics of the participants, so that the participants would be very similar between the 2 groups. So if we're using a probability sampling design, a random sample, we would need to do a number of things to be able to get our sample. So as previously mentioned, the fundamental premise of a quantitative methodology is its focus on generalizability. This requires use of a probability sample where each member of the population has an equal chance of selection. Probability sampling may therefore be defined as a sampling methodology where every member in the population of interest or in the sampling frame has an equal chance of selection. This method uses a random sampling technique and statistically implies that the sample is representative of the population under study. This is what gives us the ability to be able to generalize from our sample. There are 4 probability sampling methods that can be used, and we will begin with the simple random sampling methodology, which is the most commonly used of the methodologies. When this methodology is used, each member of the population of interest has an equal chance of selection. While this technique is relatively simple, it is not entirely suited to some research situations since it might not capture the correct demographics needed for the study. So to put this into a little more perspective, if we had 100 people in the room and we gave each person a number and we just took all the numbers and threw them into a bag or a hat, and we wanted a sample of 10, we would use a simple random sample and just pull 10 numbers from that bag or hat. That's what a random sample is. I mean, there are more sophisticated methods of getting the sample. There's Excel and statistical programs online that will just give you the sample numbers. Once you number the population from 1 to 100, it will just generate the 10 numbers, and then you will just ask those people to identify themselves, or you would number the people and physically contact them to get the sample. The systematic random sampling involves choosing every nth element in the targeted population. The sampling interval n is mathematically determined by the researchers. So for example, if our population size was 300, and we needed a sample of 20, we could start at any point in the sample. We could choose 25 as our start number and then move from 25 to 50, 75, and keep rotating it until we got the sample that we desired. Stratified random sampling should be used when the evaluator wishes to collect data on different subgroups. It requires 2 steps. First, the total population is divided into different strata or subgroups based on the hypotheses or research questions. Second, simpler systematic random selection is then used to select participants from each stratum. The major advantage of this method is that each subgroup, as well as the overall population, will be accurately represented. The major disadvantage is that the population will need to be fairly large so that a sufficient number of participants can be obtained from each subgroup, since most statistical tests require a minimum number in order for test results to make sense. So basically, this one it's a very useful methodology, but because most statistical tests require at least 30 participants, trying to divide participants into gender and then by age and then by different demographics, and you cannot maintain 30 within each group may present some complications for the use of this methodology. But often it is really important because we do need to have an equal number of males and females. We do need to have a certain amount of people within different age ranges, etc. Finally, cluster sampling is suitable when the population of interest is scattered over a wide geographical area, such as an entire country. Depending on the evaluation questions, it may be necessary to use a 1-stage or 2-stage cluster, and then we would go back to one of the previous methodologies like simple or stratified to actually select the sample. Now, another thing that you would need to consider when using a probability sampling is your sample size. The sample size is very important because many statistical tests have a minimum sample size requirement. Therefore, and because you're because you would like to generalize to your entire population, you need to make sure that your sample is credible and that you select it in the correct and appropriate manner. So you can find many sample size calculators on the web to assist with this task. I've used the Rosoft calculator, which is being shown on the screen in the upper part of the slide. And it's a free calculator. You just have to Google it with the link, or Google for any sample size calculator, and it will bring up numerous calculators. A sample size calculator generally requires 4 pieces of information. The first piece of information is the margin of error that is acceptable. Most researchers or evaluators use a margin of error of 5% or 1%, depending on the confidence interval that is being used. So you will see on this particular slide, they're using a confidence interval of 95%, therefore the margin of error is 5%. It basically indicates that we can generalize with 95% confidence that what we have found is actually true of and representative of the entire population. If you were using a 99% confidence interval, you would set your margin of error at 1%. If you do not know your population size, you generally set it to 20% and your response distribution is usually left at 50%. So with these 4 pieces of information, your recommended sample size would be approximately 377 participants. So the sample size consideration for a quantitative study is particularly important, as I've mentioned before, because many statistical tests have a minimum sample size requirement or nonsensical results will be generated. Moreover, inferences cannot be made with any degree of confidence unless the sample size is sufficiently large. It is always a good idea to also make your sample size slightly larger to cater for possible non-responses. So as you can see, we have a recommended sample size of 377 participants, but there's no guarantee that all of these 377 participants will actually respond when we contact them. Therefore, I usually recommend that we add at least a 5% to whatever number is generated by the sample size calculator to cater for possible non-response that may occur, so that we would have some additional participants that we can send a questionnaire or whatever our instrument is to gather our data. You will also notice on the latter part of the screen that we have 4 population sizes being shown at the 95% and the 99% confidence interval. Observe that when the population is very small, our sample size is almost the same as our population size. If you look at the 95% confidence interval, the sample size is actually 80 for a 100 population and 88 for a 99% confidence interval. However, the larger our population, the smaller our sample actually becomes. So it's not proportional to the population. So you would notice that when the population is at 100,000, we only need a sample of 383 for a 95% confidence interval and 99% and 660, sorry, for a 99% confidence interval. So this is very important because when your sample is really small, you have to sample practically the whole population. But as it gets larger, your sample, because of the laws of probability, dictates that your sample does not have to increase in proportion to your population size. So this is very good news that we can actually get a sample from a population of 1 million that would not be overly cost prohibitive to actually sample. If you're using a probability sampling method, which is the methodology that allows you to generalize to the entire population, you will also need to keep sampling error in mind. It arises because it is not possible to say with absolute certainty that any sample is perfect. That is, the sample will always be slightly different from the population. There are several strategies that you can use to reduce sampling error. If you were to observe every element in the population, this would be great. However, it would certainly not be cost effective, because think of if we had 100,000 in the population and we have to actually sample every person and every one of those persons, our costs would be quite prohibitive. Your best strategy is therefore to use a sample calculator to get an accurate sample size. Also, if possible, increase your sample size slightly. Finally, ensure that you have a good probability sampling design. Once you're using a probability sampling methodology, you will also need to think of your sampling frame. Sampling frames are where we actually select our samples from. At the bottom of the screen, you will notice that we have some examples of sampling frames. But the problems with an existing sampling frame is that they may not be complete, they may not be quite accurate, or they may not even be up to date. Because think of something such as a telephone directory. If you're doing a general survey on public opinion in a particular country, a telephone directory is a good first step as a sampling frame, but it actually excludes a significant proportion of our population, because many of our population do not actually, many of our citizens, sorry, do not actually use landlines, and they're only landlines that are listed in a telephone directory. So we have essentially excluded a good segment of the population by using a sampling frame such as a telephone directory, because everybody with a cell phone has been excluded. The other problem with a sampling frame is that even though it may be fairly accurate depending on the type of sampling frame you're using, so let's look at a business, a Chamber of Commerce membership list, it may still not be complete, because if the Chamber of Commerce membership list is as was issued last year, 2018, there is a possibility that new members have since joined in 2019 that are not on that current list. So we would need to actually, if we're using an existing list, we need to actually take the list and see if we need to revise the list, update it, and how accurate it actually is. Because once we have the list, we will then need to number each participant on the list and then choose our sample. So the questions to consider are, is there an existing sampling frame? If there is, this is great because it will cut down on our expense of actually having to create a sampling frame from scratch. Do you need to update it if it exists? Or do you need to create an entirely new sampling frame? With respect to data sources, there are two options that evaluators can choose from, or you may use both. Primary data is original data gathered by the evaluator. This is your better option. It is likely to be more accurate since it is specific to your data collection needs. However, it may be more expensive in comparison to secondary data and much more time consuming to collect. Secondary data is data collected for another purpose. Examples are the types of public documents such as census data, records from government agencies, etc. This type of data is more easily accessible, less time consuming, and less costly than primary data collection. However, the disadvantages are that data credibility may be an issue and data quality may be quite poor. Care is therefore needed when interpreting secondary sources, and it should be noted that such data may have serious limitations for evaluation purposes. Reliability is an important issue in data collection. It refers to the consistency, stability, and uniformity of a measure. Instruments, for example, surveys, tests, blood pressure monitors with low reliability are worthless. An instrument is unreliable if you get totally different results each time it is used on similar samples and under similar conditions. In general, researchers and evaluators strive for high reliability, at least 0.70. Reliability can also be affected by several issues. For example, poorly constructed questions and/or unclear instructions can affect the reliability of a survey instrument or test. If a pilot test reveals that particular questions can be interpreted in several ways by your pilot sample, the questions should either be written or tossed out. So a pilot test is basically a test with very similar participants as would be in your population, and you execute the instrument beforehand to at least 10 persons to get them to do the survey so that you can flag any issues that need to be corrected before it's actually executed to your real population. This will help you to correct ambiguities, questions that instructions that are not clear, etc. Evaluators need to be concerned with 4 types of reliability. Test-retest reliability requires that the evaluator administer the instrument twice to the same participants. So we are administering the same instrument twice to the same participants. The expectation is that if the same people take the identical test at time x1 and then again at time x2, that they will get a similar score. This would demonstrate that the test items are consistent or have measurement reliability and are stable over time. Observer or inter-rater reliability is concerned with the accuracy with which multiple observers or raters record or judge the same phenomena. This one is quite often used in evaluations where you send observers into the field and you're sitting and you're just observing, but the observers would need to be trained properly so that everybody's recording the same thing. For example, if we were sitting in a park just observing children playing and Valerie and I were both observing, we should both be seeing exactly the same thing. If we are not, it means one of us is either distracted or we're not properly trained to understand what we're supposed to be looking for. Internal consistency reliability seeks to determine the extent to which items in a scale or test measure the same thing or construct. And finally, parallel forms reliability requires a pre-test, post-test application using similar participants. You prepare two tests where the phrasing of questions are different but test the same construct. The questions are divided randomly into two tests. From the responses, you can then determine which one of the two tests shows more consistency, or you can then determine if both have similar consistency. Similar to reliability, validity is also of critical importance in evaluation for ascertaining if an instrument or item actually measures what it claims to measure. Evaluators need to be concerned with four types of validity. Face validity is concerned with whether the instrument is measuring what it purports to measure. Content validity infers that the instrument thoroughly covers or measures the intended content area or domain. Construct validity is concerned with ascertaining if a data collection instrument measures what it purports to measure. That is, how well are the variables operationalized. For example, if you're measuring student achievement, the construct should measure student achievement, not something else. Finally, criterion-related validity seeks to establish if the instrument is effective in identifying specific abilities. It is established through concurrent validity and/or predictive validity. With concurrent validity, we are checking to see how well the instrument correlates with another measure that is valid. And with predictive validity, we are checking to measure future performance. So for example, the GRE exams and GMAT exams that are used in the US universities are actually a predictive measure of future performance in a university in a graduate program. Those tests are used to predict the ability of the candidates to be successful in a graduate program. When you're thinking about quantitative data, you also need to be thinking about how you're going to standardize and train the personnel who will be involved in the collection of data. Bramberg and colleagues note that the key characteristic of most quantitative methodologies is that standardized indicators are defined and standardized data collection procedures are used throughout the evaluation to ensure comparability. In addition, standardization is also important to ensure general consistency in the process of data collection, data entry, and data analysis to ensure credibility and integrity of the data. It is particularly important when comparisons are being made, for example, between a pre-test and post-test or a program versus a comparison group. It is also useful when replication of the study is desired to different places or to different times. One of the best ways to ensure standardization is to conduct proper training so that the instruments can be administered in a consistent manner. The objective is to ensure that there is as little variation as possible to protect against bias being introduced. So training of your data collection personnel is really important, as well as proper training for the people who will enter the data into the database. Because if everybody is doing something totally different, we will not have any data that is credible. So that process is often overlooked, but it is really critical to ensure the credibility and integrity of the data. Once you're involved in collection of data of any sort, you need to be very concerned with ensuring that you're adherent to high ethical practices while collecting data. Ethics in data collection embody the fundamental ethical principles that are universally acceptable for conducting research of any nature. Prior to data collection, all evaluators should undertake ethics training. This training is available from many sources, including the link provided on the slide. So basically what the training allows you to do is to understand what are all the things that you can and cannot do when you're collecting data. And it's not anything that you need to be fearful about, because it's basically a multiple choice exam, they provide the answers when you're finished, and you don't actually have to hit that submit button until you are comfortable with the score that you have gotten. So for example, if they ask you a question 1 and you got it wrong initially, it will come back at some point during the exam, and you will get an opportunity because you have already seen the correct answer to know what is the correct thing you should be doing. So this test is really important to know the rights and wrongs of data collection, and we have all of these procedures were implemented because of the horrific things that were done in the early years when research was being done in the interest of progress. So there are a few other issues that you also need to consider. Is institutional review board approval required? Just generally is not a requirement unless the program has received funding. With respect to data collection, you need to keep the following in mind. Permission must be sought from participants to collect data. This should preferably be in writing. The right to autonomy is the most important ethical principle. Participants must be provided with honest information about the reason for data collection. And finally, the right to anonymity and confidentiality basically means that information should remain anonymous and confidential. So you don't want, once you've collected data, to reveal who the data is coming from. And this is a concern more in, I would say, qualitative methods, because our sample sizes are so small, and then you're reporting sometimes verbatim responses that you need to be more concerned about that. But even when you're collecting quantitative data, if it is that and you're using a mixed methods approach and the response can be traced to a particular person, you need to be very careful about actually including it in a report, because some people would be able to determine who said the particular statement. You also need to keep in mind the following additional issues. Respect for intellectual property, which deals with the issue of plagiarism. Work needs to be properly cited. Ownership and use of data. Who does the data belong to? You are collecting it, but is it yours, or does it belong to the organization, the program for whom you are doing the evaluation? Period for data retention. This is usually at least a minimum of 5 years. Data security is an important issue. How will the data be secured so that it's not accessible by any and everyone? And data disposal. How are you going to dispose of the data so that it doesn't get into the wrong hands? Measurement is also an important concept that you need to think about when collecting quantitative data. It refers to the body of rules that is used to categorize information using a numerical assignment for the purposes of comprehension and/or comparison. As this slide illustrates, measurement levels or scales are classified into 4 tiers, namely nominal, ordinal, interval, and ratio. The nominal level of measurement is the lowest in the hierarchy, while the ratio is the highest. It is critically important for the evaluator to understand all 4 levels of measurement, so that he or she can select the level of measurement best suited for the evaluation. In general, it is better to collect data at a higher level of measurement, since a higher level can be described at a lower level, but not vice versa. For instance, age, which is a ratio measurement level, can be described at the ordinal level, since it is possible to group age categories into young, middle-aged, and old using some universal definition. However, if the data was initially collected with the categories of young, middle-aged, and old, we would not be able to convert it into a ratio level. Likewise, income ratio level can be described at the ordinal level, for example, societal status, upper, middle, or lower. It is also important to note that statistical techniques that may be appropriate for one measurement level might be quite inappropriate for another level. For example, the variable religion is measured at the nominal level. Suppose you numbered Christian denominations as follows: Anglican 1, Catholic 2, Methodist 3, and other 4. The numbers do not mean anything, they're merely labels. You cannot add a Catholic and a Methodist to get an Anglican. Neither can you take the average of the 4 denominations. You therefore need to have a good good idea beforehand about the types of analysis you would like to report. If it is possible to collect some types of data at a higher level, this may be quite advantageous since it will permit more flexibility for reporting purposes. An important consideration in quantitative data analysis is whether you will be using primarily descriptive statistics or descriptive and inferential statistics. Before embarking on the use of inferential statistics, you must be fairly cognizant with descriptive statistics. You need to know your data thoroughly before moving to summarize with scores or comparisons. What is the shape of your distribution? Is it normally distributed? Do you have any outliers, a particular one-off case that would skew your data, and how do you adjust for those outliers? Your objective must be to convey information that will help your client and other important stakeholders, not to impress with complexity. Very important information can be conveyed with basic descriptive statistics. Simplicity is always best, so keep this in mind as you display your data. In contrast, inferential statistics are a special category of quantitative statistics used to infer from statistical results of a sample data to the general population based on probability rules. It is important to understand different statistical tests so that you can choose the right statistical test. For questions related to causality or relationships, inferential statistics must be used. If you plan on using inferential statistics, you must select a statistical method that matches the scale of the data collected. This means that you will need to think about the types of inferential statistical tests that you plan to use prior to design of your instrument. Chi-square and other non-parametric methods are good for examining relationships between nominal and ordinal variables. ANOVA and t-tests are useful for examining relationships between nominal and interval or ratio variables. Multiple regression is insightful for exploring relationships among variables or in exploring the independent effects of multiple variables on one dependent variable. These statistical tests would probably require a separate webinar on each statistical test for you to actually understand it in great depth. So I know it will be a little overwhelming at this point, but it's just to point out that you do need to think about the data that you're collecting and what measurement level you're using, because it will have implications for your inferential statistics. A common error when interpreting inferential statistics is to confuse statistical significance with practical significance. The statistical significance only indicates that the differences between the groups is not due to chance. The more critical question is whether differences are sufficiently large to be meaningful for program decision makers. Thus, effect sizes are often used to enhance significance testing to learn more about practical significance. So in summary, quantitative evaluation methods have a number of strengths, including findings are generalizable when probability sampling is used. Samples are representative of the population being studied, and standardized approaches permit replication of the study. Notwithstanding, they also have some weaknesses, and these include ethical issues associated with random sampling. Standardization decreases the type of information that can be obtained, and self-reported information may be inaccurate or incomplete. So to conclude, we have gone through a number of issues that you need to think about when thinking about a quantitative evaluation method. I know it may be overwhelming if you have never dealt with quantitative methods or you haven't used it very much, but you will need to do some more reading on it to get better insight into this methodology. This methodology is actually critical for us to become very acquainted with, because as we work towards the UN 2030 agenda, all of the indicators are actually going to require the use of quantitative evaluation methods to measure those indicators. So for more information on quantitative methods of evaluation, you can refer to any standard research methodology book. evaluation books with chapters on quantitative methods of evaluation, or my co-authored book, Nuts and Bolts of Research Methodology. I'm not trying to sell this as the best practice book, but we did go through over 100 research methodology books before we co-authored this book. The objective was to make it as simple as possible. So we truly believe that this book is the simplest book on the market at present. It is being sold for a very, very minimal sum. We are not going to get rich off of this book, but we really want to promote quantitative and qualitative research methodology in a way that people can understand it. So it has been designed for the novice researcher and evaluator, keeping their needs in mind. It will provide more detail on all the slides discussed in this webinar, as well as topics on future webinars on quantitative and qualitative research design, such as survey design, etc. So I would just like to quickly switch now to, I know I have to give you a few minutes for questions, but I'd like to quickly switch to another document. This is the UN's document on the indicators. And as you go through the pages of this document, which is available freely on the web, you will notice that all of, I'm not sure if you can see this. Valerie, can you actually read this information, or it's too small? Hello?
Yeah, sorry, I had to unmute. Yeah, no, it's readable. I think it's readable.
Okay,
Yep.
so you will notice that all of the indicators, if you scroll through the pages, and this document is available on the web, as I said, it's always asking for quantitative methods of data analysis. The proportion of population below the international poverty line by sex, age, employment status, and geographical location, which means that you will probably need to use a random sampling methodology, a stratified random sampling methodology to be more precise, etc., to be able to do these kinds of analyses, right? Everything has a proportion. It's looking for numbers, counting, measurement, okay? So we really need to get very familiar with this methodology because we may be working with government and are actually in charge of these indicators and need to measure them, or we may be the evaluator called in to see how the government is doing on these indicators, and we have to measure them. So regardless, for those who are terrified of quantitative evaluation, I know it sounded like a lot, it sounded very complicated, but trust me, the greatest fear can be overcome by reading more and learning and being able, when you read things more often, you get a better feel for them and understanding of it, and then it makes sense. So we do have to get familiar with these methodologies. So at this point, I'll stop and just see if anybody wants to make any comments or ask any questions.
There is a question in the chat. Othniel was asking, where in Jamaica is the book being sold? Is it available here, or do we have to do Amazon?
It's available on Amazon, but the publisher is actually a Jamaican publisher, Randall Publishing. So you should be able to get it directly from Randall. It's being sold for $30 US, which if you were to check Amazon for research methodology book, they're all like close to $200. So I'm telling you, we're just basically getting the printing costs for that book, okay? And it's on Amazon. So it's easy to secure via Amazon, and Randall themselves are selling it for the same price as on Amazon.
Randall, that's the LL. Okay,
Okay, thank you.
Nadine, I'd just like to say thank you. That was very clear summary, and I'm looking forward to getting the book. I do hope it's in Jamaica to make it easier.
Yes, just contact Randall Publishing, and they should be able to send you a copy because they're the publishers, so they will have copies there in Jamaica.
Exactly, yeah.
I mean, I'm not telling you to go to that. You notice I've said any research, any standard research methodology book, or
of course, no, of course.
We have actually really made that book user-friendly. You would have noticed I would have quoted one or two things on this PowerPoint that I delivered with diagrams, etc. And that's how the simplicity of how we presented the information, because most people get very turned off when they are reading just endless writing, and they still can't figure out how to do what they have to do with all of the writing that they're reading. So
Exactly.
we've tried to just dispel those fears. We want it to be that if you read that book from start to finish, let me turn on my video here a minute. If you read that book from start to finish, you should actually be able to understand how you would select a probability sampling using simple random sampling or stratified random sampling. What are the issues that you need to think about when you're designing a survey, etc. So
Sure.
it's here in a step-by-step process.
Thank you.
Good afternoon, everybody. Caroline Beckford. Thank you very much for the presentation. It was very intense.
I know it would be very intense if you're not very familiar with quantitative, but trust me, I have touched on all the issues that you need to be aware of. So
Yes.
what you need to do now is to get any book,
Dig in.
and just zoom into those issues, because the PowerPoint will be made available to you. I'm going to send it to Valerie as soon as we're finished, right? So
Yes, yes, I'm equal to the task, Nadine, and thank you. I just want to find out, though, I've used mixed methods before, so, you know, I'm exaggerating a little bit. But just want to ask you, if your publication, I also want to, you know, get a copy for myself. If you have practical, because one of the things I find that helps a lot is for us to actually see and feel and see the experience being, you know, shown in an evaluation, for example, right? So it would be, you know, I'm looking forward to seeing if your book has that type of flavor. Specifically, you speak about test and retest reliability and all of those different tests that we need to go through when we are doing, you know, quantitative, you know, evaluations. One of the challenges, might I say, is that the time frame within which we get to do some of our evaluations, they're so ridiculous that, you know, indeed we cut shortcuts, right? If I can put it like that, you know. So some of the methods that we would really want to employ, we throw them out of the window and that sort of thing. So for me, a conversation needs to be had with, you know, all concerned, the contractors of evaluation and we, the evaluators ourselves, in terms of, you know, what it is really that our evaluation is about. Is it just to check a box, or we really want to speak to development effectiveness? So that is, it's just, it's so difficult sometimes when you know, you're writing your methodology and then you have to go into the field now to actually implement it, you know, it's difficult.
That's a very valid point that you've made, and it's not only the time frame, but also the financial resources that you have, which will actually be able to determine that. But those are very real constraints that you do face. However, once you're going to be generalizing, these issues are critical. If you're not going to be making any generalizations from your program, we don't need to be as rigorous as we would as if we were making generalizations. So that's something that you need to keep in mind. But I do agree that we need to have a better conversation on the challenges that we face in the field and how we can really address them, because they are very real and they do limit the types of analyses that we can do and even the data that we can collect. And we know right now that as we move around the Caribbean in particular, it is very difficult to get any type of data that is credible. Most organizations don't even keep baseline data When the governments change, they move people from one department, switch people around from one department to the other. The institutional knowledge goes with them. They don't share anything that they've collected. Everything is still in hard copy form. It is a nightmare when evaluators go into government organizations to collect information and programs. And for non-geo programs as well, data is not being properly maintained. So it is a huge challenge that we have to deal with. Hopefully, with the 2030 agenda, more standardized procedures are coming in place to aid data collection. So we just have to, as evaluators, I think we have an instrumental role to play to encourage organizations to really get on board and try to collect the types of data that we need to get. But you're correct, we do need to have a really good forum and webinar just on those issues to, identify the very similar challenges that evaluators face and how we can address them.
Thank you.
Valerie here. Thank you so much, Nadine. That was awesome. Very clear. It was a lot crammed into.
It was a lot. I'm not going to say that. That's why it's something that we taught for a whole semester, but you got to get all the facts, right? So
right.
When you have the slides, you can zoom in on a particular topic to learn more about it.
Definitely. So yeah, that was what was very positive about it, because you kind of get a good idea of the whole sphere of the animal. We saw the whole elephant,
Right.
Now to cut it up into pieces and decide which one we eat first. But one of the things I know we are always challenged with as evaluators too, I mean, even some of the SDG goals are a lot kind of output level. They're really counting numbers and so on. And in terms of looking at outcomes in terms of persons' behaviors, changes in behavior and all of that. Again, it comes to the challenge of how much time do you actually have to do proper, KAP surveys like knowledge, attitudes, and, practices.
Mm-hmm.
And how do those, I've seen some of those, and, the validity again of the data, because proper baselines were not done. And so, it's, again, it just really speaks to the inadequacy of our data collection processes, and and how much work is left to be done.
It is a very challenging issue. Every evaluator knows how challenging it is. I don't have to say that myself, right? We could write an entire book on the challenges with data collection, right? But I think as an evaluator, we do have a major role to play in pushing. We're going to use the UN agenda to try to push for a lot of things, right? So everybody has signed on to the agenda. We need to get credible data collection systems in place. So we just have to keep encouraging people and encouraging them. We don't only have to, colleagues, we don't only have to push for data collection, but we have to help people to understand why M&E is so important, and to help them to overcome the fear of M&E. Because once they can overcome the fear of M&E and see M&E as something that can be used for learning and improvement, then they will collect the data. But we have a major hurdle to get them to accept that and to become less afraid of evaluators. So we have a lot of work ahead of us, that's for sure.
Thank you. Unless somebody has something very pressing, I know it's already 2 minutes past 3 o'clock. So I don't want to keep Nadine. I think she has to go off, but I
do have a class.
Right. So any additional questions or points of clarification, I'll provide her email.
And thank you once again for offering me this opportunity to share with you. I'm really happy that all of you were able to join. And I know it's a little bit overwhelming. It looks like a lot of issues, but if we want, at the end of the day, we don't want our evaluation to be criticized as well. So we do need to address some of these issues so that we can write with confidence in our methodology, so that people don't discard our evaluation as soon as they see it, to say it has no credibility, reliability, validity, etc. Hello, is there everybody still on?
I'm sorry, I muted myself and didn't.
Okay.
So yes, I'm going to circulate your email to persons here. There's some who signed up who didn't come on, so the webinar
Okay,
will be
but
made.
I also have my email address on the last slide of the PowerPoint. So if you're sending it to everybody who registered, as well as you're free to put it up on the website for all members to.
Right.
That's fine with me. I don't have a problem with that.
Okay.
I have committed. I know that I've been negligent over the last couple of years. You know the reasons why, Valerie.
Yes, man.
I'm commitment to trying to share and do my part over the next couple of years. So this presentation is fine to send to all members and to also put on the website if you wish.
Thank you so very much. And it's better late than never. We are happy to have you and look forward to more of the same.
Okay, thank you so much, everyone. I have to leave now because I do have to go and get ready for my 5 o'clock class, which finishes at 9 tonight.
Ooh, long day. All right. Thanks again.
Take care. Bye-bye.
Take care. Bye-bye. Okay, everybody. Yeah, we can speak further. Hopefully sometime early in 2020, we will have maybe more graduated courses on these topics. And I'm going to circulate a survey shortly. You can please feedback your impressions and, you know, recommendations and so forth. So with that, any further comments? Nadine has probably signed off, but we're out.